Greetings, calculus fans. Ooh, that sounded exciting. So this is our first taste of calculus, and we're doing this chapter to kind of help you guys get a little introduction to calculus, and when you guys start taking your calculus next year for the entire year, this will kind of give you a little heads up what's going on, and maybe you'll have a little bit of review for the first month or so, and it's some good practice here. Okay, so it's kind of cool because you see the word calculus in the top left-hand corner here, and it's calculus A because this is very similar to the material that I teach in my actual calculus A class. All right, so one of the really important things, especially with this chapter in calculus, is you guys need to know how to draw graphs. Okay, I cannot stress that enough because there are a lot of times on the AP exam where it's going to basically ask you to figure something out, and it's going to be based on a graph. And you guys, truly, all these graphs you have seen already. We're just going to spend some time going over them, but you have seen graphs. And I want to make a point. If you see an equation and you don't know how to graph it, what do? You plot points. Okay? So, again, we're going to kind of look at different graphs. We're going to look at rational functions. We're going to look at absolute value. We're going to look at piecewise, all kinds of different functions. So you kind of have an idea of what something looks like, but you have to understand that if you have no idea what it looks like, you start plotting a few points just to get an idea of what's going on. All right. So I even said here, graph each f of x. Include significant features such as asymptotes and holes. We like to refer to asymptotes as what? Donkey purses. Okay. Doesn't sound like you're swearing. Okay. So let's look at just basically it's a bunch of graphs here. So the first one is f of x equals x squared minus 9 over x plus 3. When you see something with an x squared, what do you try to do? Would probably look at this problem and you go, well, I know I can factor the top. And so that's what you want to do. Okay? You want to factor the top. So you're going to get f of x is equal to x plus 3, x minus 3 over x plus 3. So these cancel out. Now the thing you need to be really careful about is when you cancel something out, what does that become? It becomes a whole. You've got to remember that. We got to put 18,000 stars on that because kids always forget that. When you cancel, it doesn't just go away. It's not like it's gone. I mean, truly, okay, so let me write this out here. When you cancel, you get a whole. Again, you want to put like 10,000 stars or 18,000 stars around there. Okay, so truly your function is this now. F of x equals, if I cancel, I just get x minus 3. Well, this is a really easy function to graph. Okay, what you need to understand is you still have to have a whole at where? Well, if I cross off x plus 3 and x plus 3, do you guys agree I have a whole at x equals negative 3? I basically say x plus 3 equals 0. Okay, and I solve for that, I get x equals negative 3. So that is my whole. So let's graph that. Just like normally, you guys, if I ask you graph f of x equals x minus 3, you go, oh, I have a y-intercept of negative 3. So I plot a point there, and my slope is 1. So I go up 1 over 1. So I would graph it like this. Okay, try to hit the dots if you can. Okay, now again, this is not 100% correct because what do I have here? I have a whole at x equals negative 3. So let's kind of plot a few more points here at negative 3. So at x equals negative 3, we're going to come down here, and there's actually a hole right here. So there's not really a line there. In fact, what I'm going to do is I'm going to erase this line to give me the hole there now. So I really have a hole right here, and this is what my graph looks like. Okay? That's it. Really pretty easy, but don't forget the hole. Okay, problem number 2, f of x equals 1 over x minus 3. You guys should recognize this is a rational function. Okay, you guys learned this in algebra 1, and definitely you spend a lot of time in algebra 2 talking about these kind of functions. And you guys should know that you need, for a rational function, you need to come up with a vertical asymptote, and you need to come up with horizontal asymptotes. Okay? So let's talk about the vertical asymptote, because I think that's pretty easy. Basically, the vertical asymptote, or as we like to abbreviate that as Virginia, VA, you basically set the denominator equal to 0. So you have x minus 3 equal to 0, so my vertical asymptote is x equals 3. Again, it's a vertical line. Remember, vertical is an up and down line, right? And then you also need a horizontal asymptote. And a horizontal asymptote, you have to look at the degree. So you look at the degree on the top and the bottom. If the degree is bigger on the bottom, it's automatically y equals 0. And guys, please give me x equals and y equals, because sometimes people say horizontal asymptote and they go 0. What is 0? 0 is a number. Okay, it needs to be an equation. It's a line. So y equals 0 is your horizontal asymptote. And let me go ahead and just kind of sketch those two values in here. Okay, so here's y equals 0. All right, and then x equals 3. Let's draw 3 here. So there we go. Those are my two asymptotes. Sometimes you can have more asymptotes, but in this case it's one vertical and one horizontal. Now here's the deal, math fans. When you're sketching this, go back to the original problem. I need to know where to plot some points. And you don't need a lot of points. I need basically a point on either side of the vertical asymptote. So if I do a T-chart, my x and y, and my middle point is 3, I'm going to pick a point at 2, and I'm going to pick a point at 4. I want to pick a point on either side, and that's going to help me graph it. Okay? I'm not looking for a precise graph here. I'm looking for just a quick sketch of the graph. So if I pick 2 and I plug it in, I get -1, right? Because I get 1 over -1. I pick a 3, well, we can't do that. That's our asymptote. And then, of course, the 4 gives you 4 minus 3 is 1, so 1 over 1 is 1. So those are my two coordinates, 2 comma -1 and 4 comma 1. Let's go ahead and plot those. So 2, -1 is right here, and 4 comma +1 is here. Now it's really, you're like, well, I don't understand. That's all I have. I just need 2 points. Well, yeah, because now this is what the graph looks like. Okay, try and hit that point a little bit. And then there's the other graph. And again, please don't be messy with these. Please don't have them cross the asymptote. Remember, an asymptote gets closer and closer and closer. It approaches that asymptote, which actually is a really important thing that we're going to talk about tomorrow with limits. But it approaches an asymptote, gets closer and closer and closer. And that's my graph. Okay? So again, I shouldn't say learn how to do these. You should recall how to do these. Maybe you have to look at your Algebra 2 notes, but definitely try to remember how to graph some of these rational functions. Okay, so here's another rational function. If you see a squared term, you want to factor, because if something cancels out, that's what you're going for. Because remember, when it cancels out, it becomes a whole. So if I graph this or factor this out, it's going to factor to x plus 3 and x minus 1. And the bottom is going to factor to x plus 2 and x minus 1. Okay, so you can see these cancel, but don't just cancel them. You should write down, when you do cancel them, write down a whole. And where's the whole? At x equals 1. Okay, because basically what you're doing is you're setting x minus 1 equal to 0. Solve for x equals 1. That's a whole. So your new function, math fans, is this. That's what you're graphing, and then you're going to put a hole in there at 1. So we're going to do the same thing. I'm going to say my vertical asymptote is going to be set the bottom equal to 0, so x plus 2 equals 0, so x equals -2. And then horizontal asymptote, remember, if the degree is the same on the top and the bottom, you just use the coefficients. So you see the coefficients are basically 1 and 1, so it's y equals 1. If it was 2x plus 3 over x plus 2, that would be 2x over x, or just 2. It would be y equals 2. So that's two important things that you have here. So let me sketch these in here. Okay, so we're going to, let's see, we have x equals -2. So I'm going to go to -3 because I'm going to pick a point on either side. And we're going to put a couple things here. There we go. All right, so vertical asymptote, x equals -2. And horizontal asymptote, y equals 1. Okay, and remember what I told you guys to do is make a quick T-chart. Pick points on either side of the vertical asymptote, not the horizontal asymptote, the vertical. So I'm going to pick around -2, I'm going to pick -3, and I'm going to pick -1. I'm not going to put the -2 in there because that's it's an asymptote anyway. So if I put a -3 in there, again, I'm plugging it back into our new equation. So our new equation is this guy right here. This is write the new equation. I'm not going to worry about that x minus 1 because it cancels, and I know I have a hole there. So if I plug a negative 3 in there, I get negative 3 plus 3 is 0 over negative 1. So that actually gives me 0. And I put negative 1 in there. Negative 1 plus 3 is 2. 2 over 1 is 2. So those are my 2 points I'm going to plot. So let's do that. Negative 3, 0. Negative 3, 0 is here. And negative 1, comma 2 is here. Notice, math fans, these are kind of on opposite corners. It's pretty, I don't even think it happens where I guess it could. But a lot of times it's on opposite corners. But that's why you plot a couple points to see where it's at. Okay, it's never going to be on two of the same side because it wouldn't be a function anymore. All right, so I'm going to graph everything, but I'm going to cursor down here a little bit. I have a hole yet at x equals 1. So actually at 1, I'm just going to put a hole here. So this is what my graph looks like. Let me move this down a little bit now. My graph looks like this. Again, you don't be messy. Hit the points and get close to that asymptote. And this is going to look like this. There we go. That's that graph. Okay? So notice I got the hole. If you forget the hole, you're going to lose a point. So don't just cross stuff off. Make sure you put the hole in there at x equals 1. And that's your graph. Okay? Okay, so let's go on to number 4. We get another rational function. First thing you're going to do is what? Factor. Got to remember that. Oh, I cannot stress it enough. So I get f of x equals x squared over x times x plus 4. So I'm going to cancel that out. It's just become an x. What happens? I just cancel something out. What do you have to do? That's a hole. Okay, actually a hole at x equals 0. Okay, so your new function is just f of x equals x over x plus 4. So vertical asymptote, again, it's pretty easy. X plus 4 equals 0, so I get a vertical asymptote at negative 4. X equals negative 4. And then horizontal asymptote, remember the degree is the same on the top and the bottom. So it's 1 over 1, so I get y equals 1. Okay, so that's kind of what I need here. Let's go ahead and sketch my asymptotes here. So negative 1, 2, 3, 4. And let's actually do a couple more tick marks here. And we can do a couple that way. Okay, good. So let's go ahead and sketch that. X equals negative 4 is this right here. And y equals 1 is here. Okay, and then let's make a quick t-chart. Move this down again here so we see our function. Again, I'm going to pick values on either side of that vertical asymptote. So I'm going to pick negative 5 and I'm going to pick negative 3. So I get negative 5 over negative 1 is 5. And I get negative 3 over 1 is negative 3. Okay, so I plot those points. Negative 5, negative 5, comma 5, 1, 2, 3, 4, 5. It's going to be about right here. That's 1 point. And negative 3, negative 3 is about right here. Okay, so we got 2 points. Let's look where our hole is. What do we say? Our hole is at 0. So it's going to be someplace over here. Hole at 0. And then this is what my graph looks like that, and like that. Okay? So again, get good at it, guys, because you need to be good at it. It's an important part of calculus. All right. Next function. Well, how does this function look? If you're not really too familiar with this, you don't really remember this, you can always plot some points. You know it can't be negative, so you can only put positive numbers, actually 0 and positive numbers in there. So if I make a quick t-chart, I can put 0, I can put 1, 2, 3, but just to make it easy, do you guys agree if I put a 1 in there? I want to put perfect squares in there, right? 1, 4, and I can put 9. I mean, you can go to 16, but how are you going to plot 16? It's kind of tough, right? It's just that makes it kind of big. So square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3. So basically, if I'm plotting, even the 9, 3 is not going to be good to plot. So we're going to plot up to 4. So 4 comma 2. So 0, 0, 1, 1, 1, 2, 3, 4, 2, and then 9 would be way out here to the right, and then up 1. So if you guys recognize, that graph is kind of look like this. It's not the smoothest looking graph, but it kind of curves like this. Okay, everybody agree with that? It kind of makes a curve like that. Okay, so that's just, again, I plotted some points and figured it out. Okay, the next type of problem here is a piecewise function. So let's take a look at this. People sometimes get scared with piecewise functions because they're just like, oh, they're really, really hard. And they're really not that difficult. What you need to do, the first thing you do, and please pay attention to this, math fans, is you need points in order to where to start. So what I'm going to do is, in order to get points, you guys agree that my critical point where it changes the function is at 2. Well, let's plug that into the x value to find out what the y value is. And I get 2 times 2 is 4, minus 3 is 1. So 2 comma 1, and if I put a 2 into this equation, I get negative 2 plus 4 is 2. So those are 2 points I'm going to plot, 2, 1, and 2, 2. So let's go ahead and do that. And also, I'm going to point something out. This right here is really important, the inequality. Okay, the top one is a solid dot, and the bottom one is an open dot, because solid dot meaning greater than or equal to or less than or equal to, open dot meaning just greater than or less than. Okay, so if I go to plot that now, let's see here. So let me just make a couple of tick marks here. Okay, so I'm going to plot 2 comma 1. So 2 comma 1, and that is going to be a solid dot because it's with the greater than or equal to 2. So here's 2 comma 1, it's a solid dot. And then 2 comma 2 is an open dot. So there's your open dot. That is the first thing you have to do. Got to plot the points. Okay? So now what we're going to do is I'm basically going to graph an equation, 2x minus 3, I'm going to graph an equation negative x plus 4. Okay? People sometimes they get confused because they're trying to graph a y-intercept, and I don't need a y-intercept. What is the whole point of having a y-intercept, math fans? The whole point of having a y-intercept is so you have a point to start from, and then you use the slope after that, right? Like if I truly wanted to graph 2x minus 3, I'd go down to negative 3, and then I'd go up 2 and over 1, up 2 and over 1. But here's the deal. I have a point already. I have the 2 comma 1. I don't need the y-intercept. I can ignore the y-intercept, and I can just use the slope. So ignore y-intercept, just use the slope. So when it's greater than or equal to 2, that means it's going to the right. Do you guys agree with that? It's to the right of 2, and less than 2 is to the left, like a number line. So do you guys agree that the slope is 2? So I'm going to go to the closed dot, right? I'm going to the bottom dot here, and I'm going to go up 2 over 1, because that's my slope. So I'm going to go up 2 and over 1 from the solid dot. And there we go. That's what happens on that side. Up 2 and over 1. That's the graph. Okay? Let's look at the other equation. It's negative x plus 4. Again, I don't care about the 4. I have a point to graph from. The slope is negative x. So what do you do with the negative x? Well, I could go down and to the right. Do you guys agree with that? A negative slope is, I can go down and to the right, or I can also go up and to the left. Everybody agree with that? And that's exactly what I'm going to do here because it's less than 2. So I'm going to go, the slope is negative 1, so I'm going to go up 1 and to the left 1. And I'm going to graph it. And that's my graph. Now, some of you guys are looking at this. If I said, hey, what's the slope of that line I just drew? And a lot of you guys would say, well, it's a positive slope because it's going up. But it's not a positive slope. It happens to be pointing up, but isn't that a negative slope? If I actually drew a graph here and I did this, and I say, hey, what's the slope of that line? And you go, oh, it's negative. Well, what if I cover this up? Isn't it still negative? Of course it is. Pointing an up direction, but it's going downhill. It's a negative slope. Okay? So that's the answer right here, math fans. That's my piecewise function. Okay? So the key is you got to plot, just kind of review here. You got to plot these points first. And then you use slopes to figure out this and this. Okay? All right. So let's keep going here. Hopefully you guys recall this stuff here as we're going through this. Okay, this next one is another piecewise function. So let's go ahead and graph it. The first thing I'm going to do is I'm going to plot points. So if I put a 2 in there, 3 times 2 is 6. 6 minus 10 is negative 4. So this is 2, negative 4. And this one is 2 comma negative 4 also. Right? Because it's negative 4. There's nothing to plug into. So it's 2, negative 4. So actually, this shares a dot. Shares a dot at 2, negative 4. So let's go ahead and plot that. 1, 2, negative. So 2, negative 4 is just one solid dot. Well, it's going to go different directions. Let's go when it's greater than 2, which means to the right, the slope is up 3 and over 1. I don't care about the intercept now. Again, it doesn't matter. Up 3 and over 1. So if I go up 1, 2, 3 and over 1, I get over here where it's greater than 2. And the other one is just negative 4. Well, how do you graph y equals negative 4? You guys should know that's a horizontal line. It's a horizontal line at y equals negative 4. So here it is. That's my piecewise function. Okay? All right. Next one, an absolute value. What's the key thing with an absolute value function? You got to get a vertex. So the vertex for this one is, remember you set that x minus 2 equal to 0, so x equals positive 2. So in this case it's 2 comma 0, because it's like saying plus 0 here, right? Negative y, f of x equals absolute value of x minus 2 plus 0. So the vertex is 2 comma 0. Again, you guys should remember that from Algebra 1 and Algebra 2. And then the key here is you want to pick a point on either side because you know it's going to look like a V, right, with an absolute value. So if I put 2, 0 in the middle and I pick one point on either side, they should give me the same value. And sure enough, if I put a 1 there, 1 minus 2 is negative 1, absolute value of negative 1 is 1. Put a 3 in there, 3 minus 2 is 1, absolute value of 1 is 1. So those are the points I'm going to plot, guys. So I got, let's plot a few points here. So if it's 1, 1, 2 comma 0, and 3 comma 1. There we go. Hopefully you guys remember these. These are really pretty easy absolute value functions. Okay? This next problem is exactly the same as number 8. Exactly, except it's undefined here. And what do you do when something's undefined? Well, granted, you can put an asymptote there, but the asymptotes are only really for rational functions. If something is undefined, that's a hole. Doesn't have any value at that point. So this function is going to look exactly the same, except at the value of 2, which happens to be our vertex, you're going to have a hole. So this graph is going to look like this. Let me just do the exact same thing. So we're going to plot 1, 1. At 2, I'm going to put a hole here. And then at 3, it's 3, 1. So this is the exact same graph, except you have a hole there. Okay, so piecewise functions, sometimes you need to have, you need to break things up a little bit to describe the function a little bit better. Okay? All right, number 10. Probably a function you guys have not seen before. So let's kind of investigate it, because remember I told you at the beginning of this video, I said if you don't know how to draw a function, what you want to do is you want to make a t-chart. So let's do that. Do you guys agree here? The critical value is when that's 0. It's undefined. So that when it's 0, it's undefined. So I'm going to pick a value on either side. I'm going to pick 2 values on either side. So again, this is undefined. And let's do the positives first. They're easier. So absolute value of 1 over 1 is just 1. What's the absolute value of 2 over 2? That's also 1. What about negative 1? Well, absolute value of negative 1 is 1 over negative 1, which is negative 1. Absolute value of negative 2 is 2 over negative 2 is negative 1. So what's going on here, let's actually graph it now. The graph is a little bit below here. Is you guys are going to have a function that looks like this. Well, do you agree that if its values are this is to the left and this is to the right, anything to the left of 0 is going to be negative. So watch this. Anything to the left of 0 is going to be negative 1. So we're going to do this, and anything to the left is negative 1. Anything to the right is going to be, this is right, is going to be positive 1. I don't care. Here, let's put a big value in there. Let's put 10 in there. Well, the absolute value of 10 over 10 is 1, right? The absolute value of a billion over a billion is 1. So this is going to be positive, any going to the right. And that's what the graph looks like. It's actually an easy graph, and it's a graph that you will see many times this chapter. So know how to do that. Absolute value of x over x. I can also write this as x over the absolute value of x. They would give the exact same answer. So kind of make sure you write that down, okay? Because it can be either way. But basically, it's going to have the couple features here is going to be a hole like that, where it's not defined, and then one side is going to go to the right, the other side is going to go to the left. Okay? So let's take a look at this next one here. F of x equals absolute value of x minus 2 over x minus 2. So what you're going to do is you're going to make a t-chart. Now, where is this undefined? Because that's where you're going to have the hole there. Well, do you guys agree it's undefined at x equals 2, right? Setting x minus 2 equals 0. So 2, it's undefined, so we're going to pick values on either side. 1 and 0, and 3 and 4. So it's the same idea, guys. If I put, let's put the 3 in there. 3 minus 2 is 1. Absolute value of 1 is 1. Over 1 is 1. 4. 4 minus 2 is 2. Absolute value of 2 is 2. Over 2 is 1. All ones. What do you think the other side is going to look like? These are both negative ones. So this is look like it's exactly the same as number 10, except that hole is, or that undefined point is at x equals 2. So at 2, you're going to have those two holes. And again, looking at your t-chart, that's going to go to the right, and that is going to go to the left. And that's your answer to that problem. Okay? Not very difficult. Okay. Number 12, easy function. Vertex is going to be negative 3 comma 0. And then again, if I pick a point on either side, negative 4, negative 2. Again, negative 4 plus 3 is negative 1. Absolute value is 1. Negative 2 plus 3 is 1. Absolute value was 1. So this is pretty easy. So we're going to have negative 2 comma 1. Negative 3 comma 0. And negative 4 comma 1. So that is what my graph looks like. Pretty easy, right? Okay. Let's look at this next guy here, piecewise function. Well, the only thing that I would almost say to do here, and I wrote this purposely like this, with the negative on the outside, but if I distribute that, just to make it a little bit easier, it's negative x minus 3. So remember what I told you guys to do is come up with a point first. So if I put a negative 3 into here, negative 3 plus 3 is 0. So that's my point. Negative 3, 0. And if I put a negative 3 into here, it becomes positive 3. 3 minus 3 is also 0. So negative 3, 0. So that means, again, it shares the same point, right? So let's go ahead and do that. Negative 3, 0. Plot that point. And again, we're using slopes. So when it's greater than -3, which means it goes to the right, the slope is 1, right? Slope is 1 right here. So we go up 1 over 1, up 1 over 1. That's that side. And then when it's less than -3, it's down 1 and to the left, or down 1, it's either down and to the right, or it's up and to the left. Be careful. Remember, negative slope, always going downhill. So in this case here, it's going to be, I can't go to the right because I'm invading the other territory, and I need to go to the left. So I need to do this guy right here, up 1 and over 1 right there. That's it. The reason I have these two graphs side by side actually is because I want you to notice that these are the exact same graphs. And this is one of the things that we're going to learn how to do. We're going to learn how to make a piecewise function out of an absolute value graph. You're going to be given this, and I'm going to teach you guys how to make that. Okay? It's actually not difficult. But let's do one more. Okay, so number 14 and 15 are actually the exact same function. 14 is written as an absolute value, 15 is written as a piecewise. And again, we're going to learn how to go from 14 to 15. But I just want to point a couple things out here. If you notice that you have a change in sign here. Okay? Notice this sign's a negative sign right here, and when it's greater than, the sign stays the same. When it's less than, that sign changed to a positive. Okay, so just kind of keep that in mind, and like I said, after this problem, then we're going to actually practice how to convert. Okay, so let me kind of erase this here so we can just look at the function. Remember this, for number 14, I want to get my vertex. And the vertex is going to be 2, right? It's the opposite value of that. So 2 comma, and then there's a 3 there. It's plus 3. I know you guys are looking at it as 3 minus, but some of you guys are maybe more used to seeing that. And you're going, oh, it's 2 comma 3. There's your vertex. So then if I do a quick t-chart, I put 2, 3 in the middle, and again, remember you pick 1 on either side. 1 and 3, and then, plugging that in, I get 1 minus 2 is -1, absolute value is 1. That becomes, then this becomes -1. -1 plus 3 is 2. And this should give you the exact same thing, and it does if I put a 3 in there. Okay, so if I plot these points, okay, I get 1 comma 2 and 2 comma 3 and 3 comma 2. And it's just an upside down V, and you guys should recognize that it's an upside down V because there's a negative in front of the absolute value. Okay, pretty easy. And remember I told you this is going to be the same thing, so let's do that. Let's look at some values here. The first thing I want to do is get some points. So 2 comma, I put 2 minus 2 is 0, 3 minus 0 is 3. And I put a 2 in here. 2 minus 2 is 0, 3 plus 0 is 3. So 2, 3, and then look at the slopes. For the first one, it's 3 minus parentheses. So if I actually simplified that, and let me do that, I get negative x plus 5. If I combine, distribute the negative, and that's when x is greater than or equal to 2. And so let's rewrite that. And then this one on the bottom is going to be x plus 1 when x is less than 2. Okay, so notice the slope. Again, I'm going to plot 2 comma 3. Let me do that. 1, 2 comma 3. And then I look at the slope for greater than, which means to the right of that point, the slope is -1. So that means I'm going to go down 1 and to the right 1. And then this one is slope is +1, so it's I could go up to the right, but I don't want to go up to the right. I want to go down to the left, right? The same thing as a positive, so down 1 and to the left 1 right here. There we go. Look at that. Same thing. It's so exciting. Okay, so again, we taught you how to do some graphs. Last part here is actually showing you guys how to convert absolute value into a piecewise function. The key is to change, I even have it written here, the key is to change the sign for less than only on the absolute value part. Okay, that's really, really important, guys. Change the sign for the less than part only on the absolute value part. So let's do this problem here. I get f of x equals, well, first of all, my critical value, or my vertex, because you need the vertex for any of these problems. The vertex is going to be x equals 5. Okay, I'm not even looking for the y value. I'm just getting the x value, because I'm going to say f of x equals, and basically I'm going to show you in 2 steps here. It's positive of the x minus 5. That's when x is greater than or equal to 5. And then when x is less than 5, it's the opposite sign. That's all you do. It's really not difficult. So you keep the same sign. So I put a plus in front of this guy here. I'm basically keeping the sign. So if there was a negative in front of here, it would be negative. Okay, so this is keep the sign. So I need to finish this off, though. F of x is equal to, now I want to distribute that because I don't want to leave, no parentheses in your final answer, guys, no parentheses. So you get basically x minus 5 when x is greater than or equal to 5, and negative x plus 5 when x is less than 5. And that's your answer. That's your piecewise function. Okay? Not difficult at all. Let's look at the next one. So my vertex is going to be x equals negative 3. That's the x part. So I'm going to say f of x is equal to, and you keep the same sign, so it's the same sign, so it's x plus 3 minus 2 when x is greater than or equal to negative 3, and change the sign, so x plus 3 minus 2 when x is less than negative 3. Now, some of you guys might ask, well, Mr. Kerfus, why does one get a greater than or equal to and one get a less than? It actually doesn't matter. Okay, I could say greater than and less than or equal to because it's going to be the same dot anyway, so it doesn't matter which one gets which. Okay, so my last step is to distribute. So if I distribute that, I get x plus 3 minus 2, or x plus 1. When x is greater than or equal to negative 3, and I distribute that negative x, so I get, or the negative in front of the x and the 3, so I get negative x minus 5 when x is less than negative 3. There we go. That's your piecewise function. Okay? Not bad. But this is key here, guys. The sign's right here. Okay? Our next problem is going to show you what I mean by keeping the same sign here. So number 18, see it's got a negative there? So you're going to keep the same sign. Well, first of all, my vertex, you guys agree x equals negative 3. And so you're going to say f of x is equal to, you're going to keep the same sign. So it's negative 2 x plus 3 when x is greater than or equal to negative 3. And I'm going to change the sign. So now it's going to be positive 2 x plus 3 when x is less than negative 3. All right. So again, this sign stayed the same for the positive part because it doesn't change when when I'm looking at the right side of it. It's exactly the same as what you're given, and then when you're doing the other side, that's when the slope is basically the opposite. If you want to look at it that way. Okay. So to finish it up, f of x equals it's going to give me negative 2x minus 6 when x is greater than or equal to negative 3. And the other one's going to give me 2x plus 6 when x is less than negative 3. That's it. Okay. And one last one here. Again, it's really pretty easy, but it only affects the absolute value. And this is where kids kind of make a mistake here too. The worst thing is to do 3 minus 4. Boo! Okay, that would really be bad. That's like really horrible algebra. So you're going to keep the same sign for the positive. So it's f of x equals 3 minus 4 2x minus 6 when x, oh, by the way, what's my vertex? 2x minus 6 equals 0, so 2x equals 6, x is 3. So that's when it's greater than or equal to 3. And then 3, and then its opposite sign, plus 4 times 2x minus 6, when x is less than 3. Okay? Pretty easy, but don't automatically put a plus when it's greater. It changes the sign only to the absolute value part. I never touch that 3. Never touch the 3. Okay, so just kind of be careful about that because sometimes kids like to put a negative sign. They like to change the sign to the 3 as well. It's only the absolute value part that gets changed. So I got to simplify this here now. You can do it in a couple steps here. Basically, it's saying negative 8x plus 24 plus 3. So you get negative 8x plus 27. And that's when x is greater than or equal to 3. And then I distribute the 4 here, and I wind up getting 8x minus 21 when x is less than 3. And that's it. Okay? So anyway, that's kind of a long lesson here, but it's knowing how to do graphs, knowing how to convert to piecewise functions. Just make sure you know how to do this. The homework tonight has got a bunch of different graphs on there, and you just need to practice, okay? Because you're going to see a lot of graphs on the test where I'm just literally going to say, hey, graph these, and there are going to be other problems where we're going to say, hey, prove something's true based on a graph, and you have to be able to graph it, okay? Anyway, that's it for day 1 of Calculus A. That's it, math fans. Have an outstanding day. Adios. Goodbye.